Hmm. 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 Eh? Bawah pula duduk. Bawah pula duduk. Hmm. Okay, Assalamualaikum. Suara sedap. Dah nak ujung kelas, mikrofon baru okey. Okay, so Assalamualaikum and good morning. So today we will have a discussion on last section of this chapter, which is control rectifier. Okay, before we start to discuss the control rectifier, so I think better we have a revision. This type of the rectifier, three-phase rectifier, and the uncontrolled. Okay, for the uncontrolled, so the circuit consists of diodes. So where we can control the diode. So the diode only has two terminals, anode and cathode. Okay, so if you remember how to produce the output voltage from this rectifier circuit, so actually before we analyze on how to produce the output voltage or to sketch the output voltage, so it's better we rearrange this topology circuit to become this one. So mean you try to group the diodes into two groups. So which are the top group and the bottom group. In this case, the top group diodes are consist of what? D1, D3, and D5. For the bottom group, consists of D2, D6, and D4. Okay. So for the top groups, the cathode terminal for each diode are connected as a common point. So you can see this point, right? So mean this point, so we can define the voltage of this point as VP, VP. And for the bottom group, the anodes of each diode are connected together. So then we can define this nodal voltage as Vn. Clear? So where to calculate or to plot the output voltage, which is the difference between Vp and Vn. Is it right? And the difference between Vp and Vn. Plus on the top, bottom, sorry, the minus on the bottom. Okay, so the source voltage here, three-phase source voltage, which are balanced, same magnitude, same frequency, but different in phase to each other, 120 degrees. Okay, so the diode, the conduction of the diodes is, you can determine the conduction of diode by looking at the potential at the anode for the top group and at the cathode for the bottom group. So you can read this one. So for the top group, the diode with its anode at the highest potential, the anode. So mean here, this point, anode, here also anode for D3, anode for D5. So you need to identify which diode has the highest potential anode voltage. Okay. So that diode will turn on. Okay. In other words, for the bottom group, so you need to looking at the cathode potential here. Cathode potential of each diode. So C. So the diode, the conduction of the diode you can identify by looking at the lowest potential cathode voltage. Clear? The lowest potential cathode voltage. So only one diode will be conducted at one time. So one from the top and one from the bottom group. So the rest of diode will turn off. Okay. Clear? So please, ni lah, you revise balik. So this is the three-phase voltage from the source. From the AC side, you have VAN, VBN, and VCN. Same amplitude, same frequency, different phase by 120 degrees to each other. So before we discuss on how to derive or show you the output voltage equation. So you need to know how to the production of the output voltage. So mean you need to know how to sketch the output voltage waveform. So from the waveform, then you can derive the output voltage equation. Okay. So this is the three-phase sources and voltage. Then here actually is the line-to-line voltage. Line-to-line. So you need to differentiate the definition between the phase voltage and line-to-line. Phase voltage is VAN, VBN, and VCN. So for line-to-line is VAB, VBC, VCA. Right? So mean the difference between, for example, here you have this nodal. Here to here is VAN, right? So then VAB is plus to minus here, VAB. So this is the line to line. Okay, so same goes to here, plus B plus C. So sorry. So the difference between plus to minus here is VBC. Okay, so this is the line to line voltage. So where the line to line voltage, it has the magnitude value, the peak value, the peak amplitude value, which is larger than the peak amplitude of the voltage. So you need to multiply by what? Z3, right? Z3. So in this case, if here will be your VM, the peak amplitude of the phase voltage. So for example, here VAN, you have the function is VM, the peak amplitude sine omega t. For the line to line here, VAB, VAC, VBC, yeah. So the peak will be what? VM line to line will be Z3, right? To calculate the line to line. Square root of 3 multiplied by VM. So means the peak amplitude of the line to line will be larger than the peak amplitude of the phase voltage. Okay. Okay, so for example, if you concentrate which interval, so maybe I need to sketch the line first. Mana buat? Maybe here. Okay. Then wait here. Okay. So in this interval, okay, someone, can you identify which diode will be conducted? One from the top group and another one from the bottom group. Okay, you read this statement. For the top group, one diode will be conducted when it has the largest or the highest potential of the anode voltage. Okay, the highest anode potential. Okay, so you analyze for this interval. So for this interval phase VAN will be the largest, right? Correct? VAN will be the largest because ni VAN. This is your VAN, right? Compared to other phases, VBN and VCN. Okay, untuk top group, for the top group, so mean here VAN. Here is VAN, right? So then it will connect to this point, right? So the highest potential anode voltage will be at the diode. Is it right? Diode, eh? So mean this case, D1 will be conducted. And the rest of the diode, D3 and D5, turn off. Are in reverse bias. Okay. Okay, so mean here D1 conduct. Okay. One from the top group. Okay, the top group, the diode is conducted. You can identify the diode is conducted when it has the largest anode potential. Okay, the largest anode potential. Here, anode. So the D1 has the largest compared to others because during this interval, VAN is the largest compared to other phases. Yeah. And for bottom group, which diode will be conducted? So you need to looking at which diode has the lowest potential. Ini cathode. Where is the cathode? Here is cathode, right? So mean here, for this case, this phase of voltage is the lowest, which is VCN, right? VCN. So VCN here, right? So mean VCN connected to D2, the cathode of D2. So mean this case, D2 kan, betul? This D2 is in forward bias. And the rest, D6 and D4 are in reverse bias. Reverse bias. So mean for this interval, the diode which turn on are D1 and D2. Okay, D1 and D2. So then you can do the same thing, same analysis for the rest of the ni lah, times, right? Okay, D1 and D2. So then here you can notice here D1 and D2. Diode D1 and D2 are in conduction mode. The rest diode are turned off. Clear? Okay, so means for this interval, your VP will be what? For this interval, your VP will be VN, right? Your VN is what? VC and VCN. So to produce the output voltage, you need to calculate the difference between VP and VN. So mean this case are difference between VAN and VCN. Yeah, VAN and VCN. So mean you get what? VAC. And VN minus VCN, then you get line-to-line voltage, which is VAC. So that's why your output voltage will be here. Ni. So means your punya amplitude or the peak of the waveform, the output voltage will be larger than compared to the input voltage, the source voltage. Okay, betul eh? Okay, this is how you identify which diode will be conducted. Clear? Okay, itu just revision. Okay, so means we can say that the production of the output voltage is the difference between VP and VN, right? So where VP ataupun kita boleh buat macam ni, so mean for any time for any time your VP is what? You calculate, you identify the maximum of these three different voltage, VN, VBN, and VCN. Yeah, so means VP ni, maybe ni VP. So this is your VP. For this interval, VP is VN. For this ni, VP is VBN. Here will be VCN. VP is VAN. VBN, VCN. So you get the maximum of three-phase voltage, either VAN, VBN or VCN. Clear? Okay, for VN ambil warna biru ni. VN. So mean this case you need to identify which is the minimum voltage of phase voltage ni. Either VN, VBN or VCN. Betul So mean your VN you can sketch ni. You identify which is the the minimum voltage of the three-phase voltage. So this interval is VBN. Here will be VCN, right? Then here VAN, VBN, VCN, VN. Okay. So mean your output now. You subtract between VP and VN. The green color waveform and the blue color. So then you get this waveform, the output voltage waveform. Kalau apa nak pakai ni. So this is your output voltage waveform. Maybe I use ni. So ni. So this is your output. Okay. Right. Okay, so then you can you're able to sketch the output voltage waveform from the three-phase waveform. Okay. Okay, now based on the output voltage waveform, you can derive the output voltage equation. So VO, what is the equation of VO? So VO is to calculate the average, you mean you need to calculate the area, kan? First the area, then you divide by period. Okay, what is the period? The period of the output voltage. Is it 2 pi? Pi? Can someone give the answer? So actually to calculate VO, so your VO, the average is, you calculate the area first, the area above the time axis, you divide by T. So the question is, what is the T? T value. Okay, you have the source voltage here, right? So this is your source. Source, right? Source, and here, until here. So this is your period, 2 pi, right? Then here will be pi. Your waveform start to build up at 0 degree. Okay, so now your T, the period of your output voltage. For one complete cycle of the phase voltage, right? One complete cycle of the phase voltage. So this is your T, right? T. T of your source voltage. This is the T for the source voltage. So someone can calculate how many cycle of the output voltage. How many cycle of the output voltage? This output voltage. So you have what? So you have here to here is 1. Here 2, right? 3, 4, 5. Then you have half here. Then this one also half. So then you get 6. So that means your T will be 2 pi by 6, kan? 2 pi by 6. So mean or pi per 3. Pi per 3 mean in degrees what? 30 degrees, 30 degrees, 180 bagi 3, 60, sorry, 60. Okay, to obtain the output voltage equation, so then you need to identify the area. So the area will be here. So maybe it means you just take only one cycle of the output voltage. For example, at this interval. Okay. So this area, the yellow area. So mean here, so you need to use the integration, right? Sorry, So T is 1 divided by pi per 3. Then to calculate the area, you integrate from where? This angle, pi per 3, to pi per 3. And the function of this line-to-line voltage, is, the peak will be what? Vm or Vm line-to-line? Vm line-to-line, because this peak is, this peak, and peak of output voltage is Vm line-to-line. So then we consider this is the sine function, sine theta lah, sin theta, or omega t, d theta. So then you integrate, then finally you can get this equation. Vm line to line per pi. Okay. So the output voltage is constant. You cannot adjust the output voltage because this is uncontrolled rectifier. You use the diode. There is no term of alpha delay. Delay angle, firing angle. Okay. So you cannot adjust the output voltage. Okay, so mean here the output voltage of the output DC component of a three-phase rectifier is much higher than single phase. For single phase apa tadi? What is the output voltage of the single phase? VO divided by just only 2 Vm per pi. Okay, and this is for uncontrolled. Kalau control, you need to include the term of alpha. Okay, so before that, the output voltage equation, the output voltage, this is your output. So this is your output. So we can write into Fourier series. So actually, VO is the summation between the DC component here, VO, right, in capital letter here, VO, plus the total harmonics component. So you can calculate the coefficient of Vn or the amplitude for each harmonic using this equation. So the first harmonic is 6, n equal to 6. Then followed by 12, 18, blah, blah, blah. Okay, clear? So take note, for three-phase, the first harmonic, for this case, is V6. V6. For single phase, V2. V2. Okay? Clear? Okay, then move to ni. Division, habis. Okay, now control three-phase rectifier. So you need to use SCR or thyristor. Consists of additional gate terminal here, G. G. Okay. Okay, so here macam mana? The output voltage is different compared to the uncontrolled. So the T also same. T is pi per 3, but you need to integrate from this angle. So you have additional term here, plus alpha, the delay angle. Okay, both angle ni, pi per 3 and 2 pi per 3, you need to summing it with the delay angle, alpha. Okay, nampak So then this same function, Vm line to line sin theta d theta. So then you integrate, finally you can get this equation. Okay. No need to show lah this one. You just apply this equation. So actually you just integrate the sign, you get minus cos theta kan. Then you plug in lah, or substitute with these two angle. Then finally you can get this equation. Okay, clear? Okay, so here, okay, based on this output voltage equation, so actually it can produce two region. One VO positive VO and another one negative VO. Same goes to ni lah. When we discuss on control single phase rectifier. So then you have this output voltage. This profile of the output voltage. Okay, here. So this is positive. When you set the angle from 0 to 90 degrees, right? Then beyond the 90 degrees, you will get the negative value of the output voltage. Okay. So this is a cost function. So that's why it starts from the peak. So when you set your alpha is 0, so based on this equation, you can get the maximum production of the output voltage, which is 3 Vm line to line divided by pi, because cos 0 will be 1. Cos 0 will be 1. Then at this point, you get plus 3 Vm line to line divided by pi. So then you can test lah for any angles here from 0 to 90, then you get this profile. Then at 90 degrees, cos 90 degree will be 0. And so then you get here 0. Then for angle 180, you get minus 1. So then you get here will be the minimum, right? Because cos 180 will be minus 1. 3 Vm line to line divided by pi. Okay. So means if you set the angle 0 degrees, so mean your control rectifier will operate as same as uncontrolled rectifier. And because you set the delay angle is 0, you get the maximum production of output voltage. Okay, so this case, so mean here same thing lah, same as the single phase rectifier. This converter, we name as converter, it can operate into two modes, rectifier operation and inverter operation. So when you set your angle from 0 to 90, so mean your output voltage will be positive. So then your converter operate as a rectifier. Otherwise, it will operate it as inverter. And when you set angle from 90 to 180. Okay, this is the example if you set alpha 45 degrees. So means your converter operate as a rectifier or rectifying mode, rectifier. So mean this is the definition of alpha. And so you can see here, let's say here is 0, right? Because start to build up, here will be 90. So then at the midpoint between this 90, then you get here is will be 45. Then you inject the current pulse at this point. Okay. So then your output voltage will be like this lah. Okay. So mean this is your output voltage. Okay. So the output voltage is always positive here for the case of alpha 45. Okay. Otherwise, for the case of alpha is 150. So this is the definition of alpha. Okay. So you apply or you inject the current pulse here at this point, right? And for example, this one for T1, T1 and T2. So then your output voltage will be down here. Okay. So mean the negative area, it for the negative area. So this is the output voltage waveform for the case of alpha 150 degrees. Okay. So for three phase, I cannot illustrate to show you on how the generation of current pulses for each thyristor is difficult. And three phase, and single phase, okay. If you're interested to know how to design the current pulse, so maybe I will provide after this the simulation. Then you try to analyze. Okay. Difficult for me to sketch because three phase waveform. You have phase voltage, phase voltages, you have line to line voltages, and okay. All right. Okay, now exercise. Okay, finish. And theory part finish. Then we can move to exercise. Okay, nak rehat dulu. Rehat. Take 5 for 10 minutes. Take 5, 10 minutes. Break, 10 minutes. Take 5 minutes je lain. Division. Dah tak payah tu. Senang tak payah dia.
Yang ni kan, macam mana yang kalau yang ni kita nak tahu yang mana daripada atas dengan bawah ni, dekat atas ke dekat bawah? Ini mana atas?
Tu pasal saya cakap tadi. Saya tak boleh nak explain. Kalau nak tunjuk detail, tunjuk pas, susah tau. Sebab textbook pun tak ada orang cerita. Sebab dia kena faham sendiri je. Dia kena dah tengok benda tu, dia kena tunjuk simulation. Tapi nak tunjuk simulation pun banyak. Nak kena deal banyak waveform. Sebab kita ada 6 switch tau. Pas kita pun ada banyak tau. Dia bukan on secara berpasangan tau. Macam kalau single phase, T1, T2 dia pakai current pass sama. Lepas tu T3, T4 current pass sama. Tapi untuk 3 phase dia lain. T1 dia individual tau. T1 mungkin T2. Tapi lepas tu T2 pula dia dengan T3. Dia susah nak explain. Pasal textbook pun tak tunjuk benda tu. Sebab dia difficult to explain. Melainkan kalau you betul-betul buat, you kena tengok simulation saya bagi, you analyse. Kenapa kau buat main PSM ke?
Tak lah, tu tanya.
Yang akan tanya.
Tapi kalau saya ni ni doktor, macam kalau lebih ada 45 degree tu memang dia start ada bawah macam.
Nanti saya tunjuk simulation. Simulation lah. Maybe ni, this simulation. Susah nak explain. Current pass tu. Kalau nak tengok. Ni, dia blok ni. Saya rasa mungkin dalam blok ni dia explain. Tak adalah. Alah, dia tutorial ni kosong. Ni apa? Susah. Nak plot waveform tu banyak tau. Ada 6 tu. Macam ni. Kalau nak tengok macam ni. Macam ni cepat tadi. Saya cuba try ni tunjuk. Mana tadi? Ni ataupun ni pun boleh. Ni. Mana nota ni? Ni yang tadi ni. Oh, ni susah pula. Tak ada ruang. Dia current pass macam ni lah. Ni lah. Tekan ni untuk. Yang ni untuk. Kan? Yang ni untuk T1. T1 dia punya tu T1 yang ni. S1. S1 kan? Lepas tu S2. S2 kat sini. Dia tak macam single phase tau. Single phase dia current pass yang sama. S1 dengan S2 current pass yang sama. Tapi kalau 3 phase, S1 on, macam ni S1 dengan S2 kan. S1 on. Lepas tu, macam mana? Ada buku had tak? Saya tak ada share reference. Mana buku had itu? Textbook. Aduh, kat mana textbook? Ya, cek. Tadi apa power system tu Ni 3 phase ni. Ni tengok. This one for uncontrolled. Tapi kalau you looking at for uncontrolled ni, dia bukan on in pairs tau. Dia thyristor. Yang ni contoh ni D1 on. Sebab D1. D1 kan sebab D1 ni current ni. Ini positif. Asal tak keluar pen ni? Alamak. Tengok telefon ni. Dia ada. Kalau tengok kat MATLAB, you try cari yang firing angle unit tu. You jangan ambil discrete tau. You ambil yang continuous. You klik block tu. You right click. Awak klik help. Nanti dia akan tunjuk description macam mana generation of pass. So, dia tunjuklah ada gambar dia. Kalau saya nak cerita dalam kelas ni, tak cukup lah kan, lambat. Tapi memang menarik lah kalau nak buat simulation. So buat FIP nanti kalau siapa ni kan, kalau buat jadi pensyarah kan, students design block tu je, firing angle. Macam mana nak jadi current pass. Ni. Macam ni D1 kan. Ni D1. Macam tak keluar lagi ni. Jadi D1 kan, D1 kan. So ni D1 on. D1. Tapi D1 ni pula, dalam masa D1 on, dia ada D6 on. Ni D6. D6 kan. Lepas tu ada yang lain pula. D2. D1 on. Dalam masa D1 on tu ada dua diode lain yang on. D6 and D2. Kalau for single phase, dia senang. T1, T2 same current pass. T3, T4 ada serentak. Tapi ini dia susah. D1 untuk dua cycle tu. Dalam dua cycle tu ada D2 on, D6 pun on. So kalau saya nak sketch tu, memang berserabut lah. Faham tak? Nah, three phase tu nak mula tulis, you kena lukis single phase. Lepas tu dalam waveform yang sama, kalau boleh kita plot in same graph lah. You kena lukis line to line pula. Dia ada VAB, VBC, VCA. Lepas tu nak lukis current pass. Bawah-bawah memang tak cukup muka surat. So saya tak terang kat sini. Kan? Tapi kalau ni, okay. Final tak masuk sini, final senang je. Final you just, for final exam, you just concentrate my exercise. Terang aku cakap. And no need to worry lah kan. The way, macam mana the production of current pass kan. Okay. That one just knowledge. Okay. Concentrate on my exercise. Exercise provided. Tenang subjek aku ni.
Apa ni kan ada nak buat assignment kan. Tak ada nama dalam list tu. Kalau bila boleh datang lagi?
Bila-bila lah.
Bila-bila?
Khamis ni boleh kot kalau nak datang.
Kami pagi pula.
Khamis ni sebenarnya saya nak prepare untuk part time. Tapi boleh lah kalau nak datang.
Kami tu lagi
boleh. Satu hari Khamis tu boleh. All day.
Pukul berapa doktor? Sampai pagi tu.
Tapi tengok kekosongan lah. Takut ada grup lain pun. Itu kata macam nak datang juga. Boleh lah awak datang. Itu dia satu grup. Awak masuk grup boleh lah.
Sebab masuk hari tu kan dalam list tu full kan.
Tapi Khamis saya ada lab lah. Pagi.
Tu cakap. Tu cakap doktor ada pagi lab.
Awak buat dulu. Nanti masa nak test tu panggil saya. Saya datang kejap.
Yeah.
Tapi boleh awak kan. Dia biasa pakai display apa. Boleh. Khamis petang lah kalau nak. Khamis petang. Boleh. Okay. Dah habis dah? Belum? Okay, class. For your further reading, so maybe my notes is not sufficient for you to ni. So you can find this book. Title is Power Electronics. So written by Daniel William Hart. Dah nak habis baru nak beritahu So ini sama kan, same textbook kan for subject Power Electronics kan. William Hart. Actually you can Google. Just Google. Then you can obtain in PDF version. For SVM ada satu buku. Kalau SVM you just concentrate my notes, okay kot. Sufficient. Siapa group yang buat assignment semalam? Ada dua group semalam dia dah record video. It's complete. Bolehlah share video tu dekat WhatsApp group. Biar kawan-kawan lain tengok. Dan kawan-kawan group lain tu lebih buat yang lebih baik daripada dia. Okay. So let's continue to discuss ni exercise 5. Exercise 5. So this case, 6 pulse converter. Why we call it as 6 pulse? Because you have 6 thyristor or 6 current pulses. So actually to run for the 3-phase control rectifier, you need to produce 6 individual current pulses. 6 individual. It's not same as single phase, because single phase you have the thyristor on in pairs. So you just generate only 2 current pulses. One pulses to control T1 and T2. Another pulse for T3 and T4. But for 3-phase, actually you need to design or generate 6 individual current pulse. Okay, I will not discuss in detail on how to design the firing angle unit or current pulse generator. If you're interested, you can come lah. I can explain in detail to you. Okay, so this converter has alpha 120 degrees 3-phase AC system. The source AC system is 4160 volt in RMS, line to line. DC source is 3000 volt, R2 ohm. So in the first part, you need to assume the R is large enough so that the current ripple free lah. So mean there is no current ripple untuk the first part in part A. Okay, in part A, you need to determine the power transfer to the AC source from the DC source. In part B, determine the value of L so that you can limit the current ripple by 10% of the average load current. So this part, question, it gives the design specification in percentage. Before this, for single phase, they dah specify kan, you need to limit 1 ampere, 2 ampere. But for 3-phase, they give the design requirement in percentage. 10% of the average load current. Okay, when you have get this question, firstly, I recommend you to sketch the circuit, the system. You have the AC sources here, the bridge, and the load side, which consists of RL and DC voltage in series. Okay, so since the alpha given is larger than 90 degrees, so automatically you can identify the operation of the converter operate as inverter, inverting mode or inverter operation. So means your sketch, the DC voltage polarity must correct, where the positive sign must be at the bottom, the minus will be at the top. So make sure you sketch the polarity must correct the polarity of the DC source, because this converter operate as inverter, inverting mode, because your alpha is 120 degrees. Okay, solution. So firstly, you need to calculate the output voltage, because in part 1, you need to calculate the power transferred to the AC system from the DC source. So firstly, you need to calculate the output voltage. So here 3 for VM line to line. Okay, so here given is 4160 volt RMS line to line, kan? Dia dah bagi line to line. So mean to calculate the VM line to line, you just multiply only by set 2 because line to line. So RMS you need to convert to the peak value. So 3 4160 you multiply by set 2. So divide by pi cos. Okay. So then you can obtain this value 2809 volt. Okay, for the output current, how to calculate the output current? Okay, so this one you need to simplify lah the circuit. So maybe you can just sketch the simplified circuit here, as here the output voltage of the converter you can represent as the DC source. So this voltage is VO. So you just sketch for R. L you can ignore. For DC analysis, you can neglect the effect of L. So then you have the DC source here. Plus at the bottom, minus at the top. So this is your VDC. Okay, so your current direction maintain. Remember, for the converter operate for both operations, rectifying mode and inverting mode, the current direction is maintained. Means your current always positive. This is your IO. So here is R. So based on the simplified circuit, so actually you can obtain this equation. So where your IO, or maybe you can write here as a VO, what? VO minus IR, IOR plus VDC 0 by applying Kirchhoff voltage law. So then you get this equation, then you rearrange to calculate IO. So your IO is VO plus VDC divided by R. So here, VDC is what? 3000. 2 ohm. Okay. Okay, then next page. Boleh semua dah? Okay, next page. You calculate the power absorbed. So power absorbed is PAC. PAC, P sub AC. Multiplication between minus VO and IO. So VO is minus. So don't forget to put minus here. So based on the calculated value in previous page, VO is minus, right? Minus, you have minus here. 2809 multiplied by IO. IO is 95.5. Then you get 268.3 kilowatt. Power supplied by the DC source, VDC. So VDC is what? 3000 multiplied by IO. Very straightforward question. 286.5. Okay, you have three powers. Power absorbed by the bridge, power supplied by the DC source, and power absorbed. So RMS current and output current, we can consider same value. So here 95.5 squared 2 ohm. Then you get 18.2 kilowatt. Okay. Okay, then you can double check lah your calculation. So make sure this equation is fulfilled or satisfied. So you have the total power must be VDC. VDC is summation between what? The losses and the power absorbed by the bridge. Okay. Okay. So please check. Okay, then next page. Part B, part B. Part B ni, this part you need to design or calculate the appropriate value of inductance. so that the current ripple can be limited. So first, in order to simplify your analysis, you need to provide the assumption where the variation, the peak-to-peak current variations is mainly influenced or affected by the first AC term. So for the three-phase, N will be 6. So where the first AC term is what? I6. For single phase, I2 for single phase. So where from the design requirement given in the question, so you need to limit the current ripple 10%, 10% from the average current. So here is what? Current is 95. Then you multiply by 0.1, you get 9.55. Okay, so where the current ripple, so actually is what? 2 times of I6. The peak current, the peak of the first AC term, current ni, I6. Betul So remember your punya current ni, so this is your current. So you have the AC current component here. So this is your I6. Ni I6. Here will be your I6. I write in small letter ni. So mean your current ripple here, the peak to peak of I6 actually is what? The change of IO. So that's why we consider or assume the current ripple, the output current ripple is mainly affected by I6 and the peak to peak of I6. So where the peak current here, right? So here will be I6. So means the current ripple is 2 times of I6. Clear? Okay. So mean from here you can calculate I6 as what? The change of IO divided by 2. The current ripple, the output current ripple divided by 2. So mean here, tulis 9.5 divided by 2, which is 4.775 ampere. Okay, then next step, you need to calculate or obtain the required load impedance. So this is from this general equation, remember, Zn divided by Dn per In. So this case n is 6, because we consider only the first term, which is 6 order harmonic. So in order to calculate the or obtain the load impedance, so you need to estimate first V6. So V6 you can estimate from the graph below. Simple lah, same procedure kan, like single phase. So your alpha is what? Based on the question, alpha is 120 degrees. 120 Okay, saya sketch. So this line you sketch. Go to where? Okay. So your angle here is 120 degrees. So then here, this point will provide what? The information of what? Because we consider only the first term kan? So you can just analyze using this curve for V6. Okay. So means this point actually you calculate what? V6 divide by, ini kena betul Vn. Don't forget to put in line to line. So actually the peak of line to line voltage. It's not the single phase apa kan? Single phase pula apa? Ialah phase voltage. It's the line to line voltage, not the phase voltage of the peak. The peak of line to line voltage is not the peak of the phase voltage. Okay. So where here you get, you estimate from the graph, you get what? So maybe 0.28. Okay, so then from here you can calculate V6, the first AC term, the phase voltage, 0.28 multiplied by what? Money. So the question given in RMS, line to line. So then you need to calculate peak and peak value. So you multiply by Z2 and 4160, right? So here you get 1647.3 volt. Okay, then from here you can calculate the required impedance as I6. So then you get what? 345 ohm. Okay. Okay. Then next page, the last page here, you can write macam ni lah. So you have to apply the second assumption in order to simplify your analysis, kan? So where your ohms, the resistor given value, what value? 2 ohm, 2 ohm. You compare with the total impedance that you have calculated. Next, previous page is 345 ohm. So where the resistance values is too small compared to the total impedance, then you can neglect R. Okay? So then you can reduce this equation as N omega L. Then from here you can rearrange the equation, the above equation, so that you get here, kan? Z6 divided by, and this one is N omega. So mean here Z6 is N is 6, 2 pi. Frequency given is what? 50, 50 hertz. So the answer is 183 Henry. Okay, finish for exercise 5. Can we have another one class next week? Next Tuesday. Last class. Promise. Okay. Just only to discuss only one exercise only. Because for this case, based on this exercise, we punya DC voltage is the solar cell. But for the next week, so maybe you can represent the DC voltage using the DC generator. Last exercise for the next week. Okay. So maybe class on next Tuesday. On next Monday, no class. And not Monday 11 to 1 to no class. Okay. So maybe you can have the last class on Tuesday. Okay? Just only one exercise, maybe half an hour finish. Okay. Okay, exercise 6. Exercise 6. Okay, this energy source array produced 2000, very large voltage here. So actually this question I took from textbook, Daniel William Hart. So the resistance is 0.2 ohm. So they give the design specification where the peak to peak current variation cannot exceed 10% of the average current. Lepas tu you ada source, kan? Source voltage here in line to line, RMS, 50 Hz. So you need to design the system to transfer power 2000 kilowatt, 200 kilowatt. So this case you have the transformer. Special this question, you must include ni. Your punya equation you must include the transformer turn ratio. So you need to obtain the design control parameter. For example, the delay angle, the value, all the inductance and so on. Okay. Boleh? So ni So bila you dapat question, so make sure the first step you sketch the circuit or the system. From the sketch you can get the idea on how to answer the question. So please sketch. Okay, sketch properly with correct definition of polarity semua kan, plus minus. Okay. Okay, solution. Calculate the output current. Macam mana buat? How to calculate the output current? Someone can give the answer. IO. Oh, 9,5. IO. How to calculate IO? Based on information what? You have 200 kilowatt here. The AC power. So mean here, IO you can obtain based on this equation, right? PAC, the power absorbed by the bridge is minus VO IO, right? So then from here, because PAC is given, so then from here you can, okay, here is 200 kilowatt. Okay? So then you rearrange. Okay, IO dulu, VO. So you need to calculate VO first, sorry. Oh, okay. So this case is not straightforward. So here power is 200,000 ni. Divide by what? IO. You just put in general here. Okay? So this will be equation number 1. Okay, Kirchhoff voltage law give what? So based on simplified circuit and so actually you can get this equation, right? VO IOR plus minus. For inverter operation, this will be minus. But for the rectifier operation, this one will be positive. Okay? So it based on the polarity of the DC voltage. For rectifier, your DC voltage positive sign must be at the top. For inverter, positive sign at the bottom. So that's why here you get minus. Okay? You can draw the simplified circuit here. At this part. Okay, then here VO, IO, RO. Okay, based on this equation number 2 ni. So you substitute VO you get from equation 1 into equation number 2. Ni. So mean you need to substitute VO here using equation number 1. So mean here you get 200,000 IO. Okay lah, tak apalah. IO R minus VDC is what? 2,000. Okay. Saya copy lah. Kita nak tunjukkan kan. Okay, then next page. Actually from here, you need to rearrange the equation to form a quadratic equation. So mean here dapat macam ni. IO squared R minus 2,000 IO plus equal to 0. So this equation number 3. Right? So you have quadratic equation. So then equation 3 actually yields the 2 roots. Okay. You can have 2 answer for IO because of ni. Polynomial 2 ni. So man, you can apply this mathematic ni, theorem ni apa? So if you remember right. Sorry AX squared plus BX plus C equal to 0. So in order to calculate or solve for X, so actually you can use what? Plus B. Thousands. Saya dah lupa. Someone can give 2,000 is Okay, minus B, minus B, plus minus square root of B squared 4AC, right? Betul. Then you divide by 2A. Okay. Tak lama tinggal matematik ni. So from the above equation, for equation number 3, then you can solve for IO as plus 2000 plus minus B squared. B squared is 2000, right? 2000 minus, or A is what? A is R, A is R, which is 0.2. Then C is 200,000. Okay. Then you divide by 2A. A is R, the resistance value, 0.2. So then you can apply your calculator. So careful, Then you use calculator, then you can calculate, then you get two answers. Because you have plus minus. You need to test for each. Inilah sign kan, plus and minus. Then you get two roots. IO is 9899 ampere or 101.02. Okay. Right. Okay, you have two answer here. So you need to choose one. So which one you prefer? 9,000 or 101? 101 because of what? Give the reason. Choose IO as 101.02 ampere because this solution, apa ni? This answer results in or give apa? Lower I squared R losses. Okay, and so it produces lower losses if you choose 101.02 ampere. Then from here you can calculate the output voltage based on the selected of the output current. So you need to apply equation number 2. So where VO is IOR minus VDC. Your IO is 101.02, 0.2 thousand minus 1980 volt. Okay, we know that your VO equation for 3-phase is 3 VM line to line divided by pi cos alpha. Okay, 940, 938. Okay, gini. Okay, then next step you need to calculate the required delay angle. Using this equation, you rearrange from here. Then alpha you can calculate as what? Oh, sorry. In order to calculate the delay, firstly you need to get this value, VM line to line. So remember you have the transformer in between the sources voltage, AC sources voltage, and the bridge converter, right? You have the circuit, you have the transformer between the bridge and the 3-phase sources. So you need to include the transformer ratio N1 and 2, right? N1 and 2. the transformer ratio in your calculation or equation. So this case, okay. So here is your transformer. Okay? So this one you connect to the bridge. Eh? So this you connect to the bridge. Here from the AC source, right? Padahal. So here, based on this equation, so actually the VM line to line you define here, right? VM line to line. Okay, betul eh? VM line to line you must define at the primary, secondary side of the transformer. So the primary side, so you need to calculate the peak voltage of the primary side. Macam mana? So here will be what? So based on the question given apa? Your V line to line kan in RMS eh. Macam mana tadi? Question here is what? Ni 228 kilovolt line to line RMS. 22.8 maksud dia. Here will be 228 kilo. Ni line to line RMS. So then in order to get, because this is in RMS, in RMS, sorry, in RMS. So then to get the peak value, because secondly we define the peak value, so means same goes for the primary side, peak value. So the peak value of the primary side will be what? 22.8 kilo, then multiply by Z2. Both voltage is line to line. Secondary line to line, primary also line to line. But you need, at the primary, you need to multiply by square root of 2, Z2. Because you need to get the peak value, VM, of the primary side of the transformer. Clear? So mean your VM line to line is what? Sorry. Macam mana? Okay, betul lah. VM line to line, the secondary. The secondary, in order to get the secondary peak line to line voltage equation at the secondary side, so mean you need to include the transformer turn ratio. So mean here will be N2 kan? N2 N1 multiply by 228 kilo Z2. Is it right? And okay, then you may write based on the equation above here. So then here is BO is 19805 3. So where your VM line to line is what? N2 N1. Okay, ni. So your VM line to line now is include these terms. Okay, so you need to include the transformer turn ratio in your calculation. Okay. Sembilan 42. Sebab ini sikit. Okay, then from here you nak calculate the alpha ni, the delay angle. So let's say you set the value of the transformer ratio ni, actually is the inversion of the transformer turn ratio because N2 divided by N1. So let's say you set N2 N1 is 1. Actually it's okay, but you just write ini. And if you set N2 N1 is 1, will theoretically, ni saya ambil ayat buku ni, theoretically work. Dia boleh, but your alpha will be, you use calculator, you calculate, you substitute N2 N1 is 1, then you calculate alpha using calculator. So actually you get alpha is 93.69 degrees. What is the problem? If you choose this transformer turn ratio N2 by N1 is 1, so your alpha will be 93. The problem is Ada? Ada pun nak buat ni. And the harmonics content will be small or large? Large. That is the problem. Actually, in design, so we try to minimize the harmonics component in order to get your output voltage close to sine wave shape. Okay? Kalau sine wave shape means harmonics component is insignificant. Insignificant. Okay? So that's why we try to minimize the harmonics component. So this case, if you choose your transformer ratio N2 N1 is 1, the alpha will be 93. So this will give higher harmonics component. How to justify why this angle selection give large harmonic component? So you're looking at the graph, this graph. Buat graph ni. So your punya angle now around this angle 90 degrees. Ni 90 degrees. So kalau you project the line, so then you get your harmonic component will be large. So that's why we prefer to choose ni angle ke sana. Ni kan. So when you choose larger angle, larger delay angle, so mean your harmonic component will be smaller. So mean your THD small. Then you can get close to sine wave shape. Okay. Ni saya padam. Okay, then go to here. So then this is better solution will be to choose N2 per N1 equal to what? 10. Sorry. N2 per N1 to be perhaps 1 divided by 10. So mean your transformer is step down transformer, right? Step down. So it will step down the output voltage. Let's say lah in your final your question like this, to make sure you choose this transformer turn ratio. So then you can I can have same answer lah. Kalau masuk lah if the question like this Okay, 1 per 10. Okay, then you just substitute from the equation above ni kan, daripada atas ni. Here. Sikit lagi. 1980, saya just rewrite je. Pi divided by 3. So now your transformer ratio will be 1 divided by 10 to 2.8 kilo set 2. Okay. You boleh compare. So maksudnya I just substitute the transformer ratio as 1 divided by 10 here. So this is your transformer ratio. Okay. And then you use calculator, then you can get this answer 30 degrees. Okay. Then next page, you estimate the V6. Same procedure kan. Tadi 130 130 will be somewhere else here, right? Here will be 40, 46. Which one? Here. Mata pun dah tak betul dah ni. Right? So then connect to here. So this angle is alpha. Okay, where the y-axis provide the information of what? So this point information of V6 divided by. So don't forget, this one is line to line. Peak of line to line voltage. So equal to what? 0.26. Ya ke saya punya? Saya punya 0.26. 0.26. So then here you can calculate or estimate V6 as 0.26 multiplied by VM line to line. Right? VM line to line. So where your VM line to line is apalah? VM line to line berapa? You ada rate transformer ratio 1/10 to 2.8 kilo. Don't forget to put ni set to because peak value, right? So then get 838.25 volt. Okay. $9.50. 10 minutes more. Okay. So then here from here, the required current ripple should be less than 10% of IO, the DC component. So mean here 0.1, 101.02, or you can write as ni 10.102 ampere. Okay, where assuming that the current ripple is mainly affected by the first term, which is I6. Because this is three phase. So where change of I2 or the current ripple is 2 times I6, which is should be less than 10.102 ampere. So from here you can calculate I6, which is berapa? 10.102 divided by 2. And you get 5.051 ampere. Okay, sama je, same process kan? Like as a single phase. Okay, then I6. Boleh dah. Mudah dah salin. Finish. Okay, move to the last page. So from here, since the resistance value, ada lagi ke? Oh, ni atas. I6 is less than or equal to 5.051 ampere. So it means I6 is V6 divided by Z6, which is less than or equal to 5.051. So from here you can calculate Z6 larger than, and you rearrange the above equation, you get here. Dia apa? 8. Betul? Divide by I6. So actually you get Z6 must be larger than 165.98 ohm. Okay? So the given 0.2, very small. Small value compared to the total impedance 165.98 ohm. Then you can neglect the resistance value. So then this equation can be reduced to, or you can approximate to n omega L. So by rearranging the equation, then you can solve for L. Okay. 6 to pi. Frequency is 50 Hz, right? Betul? 0.0881 Henry. Okay, finish. Actually, when you compare, or maybe we can, based on the observation kan, from exercise for single phase and three phase, you can notice that in order to minimize the output current ripple, for the three phase, it requires small value of inductance. Apa? Betul Kita tengok ni. Inductance, the required inductance for three phase will be smaller compared to the single phase. So that is one advantage of using three phase rectifier. So you just buy small size of inductor. Okay. Sebelum habis simulation, tu lupa nak tulis simulation. Sekejap. Simulation. Last. So this is the 3-phase. So this file I will provide. So after this, every material and my notes, my tutorial solution, simulation file, I will put in Microsoft Teams. So then you boleh prepare for your final. Okay, ni bridge your punya RL same as in the question kan. Ni yang you dah calculate kan, you dah design in part B tadi. Your DC is 3000. So this is the 3-phase voltage. For 160 square root 2 divided by square root 3 because this parameter block required the value of peak and must be in RMS. It's not line to line. RMS RMS. Phase voltage must be in phase voltage. It's not the line to line voltage. So that's why you need to divide by square root of 3. Okay. Frequency 50. Okay, then kita simulate lah. Simulate. I think this one takes time. Nampak lah. Okay. Slow running because very complicated algorithm. So actually, if you interested the way to produce the current pulses, so you can study this block. Actually, this block I took from MATLAB toolbox. You boleh set your punya angle here. Angle ni 120 here. 120 degrees. You give the input to this block. Alpha must be in degrees. So in order to generate the pulses, so this block require information of the line-to-line voltage. So that's why in practice, you need to measure the line-to-line using the voltage sensor here. So this can be represented as voltage sensor. Because dia nak ada guide kan, when the pulse need to produce. So dia kena ada guide ataupun reference waveform, reference signal. Dah keluar dah? So this is the waveform. I bagi kat min sikit ni. This is your phase voltage. The output voltage waveform. Okay, you can see here is your phase voltage AN, BN, CN. Sorry, this is line to line. Sorry, it's not the phase. It's the line to line voltage. VAB, VBC, VCA, and the white color is the output voltage. So since we said the angle is 120, so that's why you get negative voltage. So your VO, by calculating the average component of this white color of waveform voltage, so then you get your VO will be minus 2811. Jadi kita buat apa? 18110. 10. Okay lah, similar lah, close to the calculation. So how about the current ripple? Current ripple mana? Where is the current? Output current here. Output current, right? So this I measure the output current. Ni this scope. Here you put the current measurement. Then this will give the current average current component. So of course you need to put the mean block to get the average component. You dapat apa tadi? The calculation is 95. Close lah. Okay lah tu. Then the output current waveform here. This is your output current waveform. Okay. Is it right? Output current. Actually, we just analyze when the current is in steady state. Ini dia nak start to build up. Dia ada inrush current. And during start up, then dia akan goes to the steady state. So we analyze for the steady state here. Okay, ni your current. So your current is continuous. So then you boleh baca lah dia punya ripple. Berapa ripple ni? This is your current, right? Calculate. 98 and 86. Berapa? Then you compare with the calculation. Maybe dia ada error lah. Okay? That's it. Any question? Boleh balik. So thank you for coming. So don't forget, last class next Tuesday. Okay? Belum? Tunggu lagi. Sempat. So I will provide the exercise question. Inilah next week. Okay, guys. If possible, if I give the midterm question number 2 on this Thursday. So here now to this Tuesday kan. Come in this Thursday. One day you need to answer one day. Boleh? Because next week every one of you busy kan for Radiate FIP seminar. So I think maybe we can do the test this week, this Thursday. You can do by group. Take home test. Boleh? Is it okay? Okay. This Thursday I give the question through WhatsApp group. Then you can discuss among in your group. Then you need to send the answer email to me. Your calculation must be in handwriting. No need to type, handwriting. Then provide the simulation file. So actually in the question I give to you the incomplete version. And it means your simulation is not completely connect. The setting maybe not proper. So then your task you need to completely do the connection and provide appropriate setting. And the value of phase voltage and the parameter block for the source voltage, the delay angle. That's one. And you need to design the current path. For single phase only. Single phase, control single phase rectifier. 3-phase not ini. And for the midterm cover for only control single phase rectifier. Okay, control single phase rectifier. So mean you need to study exercise what? So please study exercise. Mana tadi? Why not? Which exercise? Here, ni. Exercise 3 and 4. Okay. You study just only 2 exercise. I think you can answer the question. Okay, this Thursday. I give the question through WhatsApp group. Start early in the morning. Okay, you have sufficient time for you to discuss. Okay, all right. Thank you.
Okay, Doktor. Thank you, Doktor, untuk hari ni. Doktor, nak tanya. Cik, nak tanya. Nanti nak datang, nak balik Doktor free bila?
Sebenarnya, datang bila kami sekarang. Awak akan tengok bergantung pada kekosongan.
Kami
Kami pun ada tadi tak datang nanti. Walaupun saya sebenarnya saya nak prepare untuk part time, tapi saya boleh buat duduk kat bilik tu lah. Tak banyak sangat pun kerja.
okey.
Ya.
Lepas tu